Hello, hello. Okay, just checking. Just checking if things are working. Okay, this is working. Hello, hello. Okay, so, good evening, Ekelus. How are you on this beautiful night? Hello, I'm good. Thank you. Thanks for asking. And how are you on this evening? Yeah. Hello, Tyler. Hello, hello. Good evening. How are you? Okay, just making sure things are working. Let me see on YouTube as well. Okay, it started on YouTube as well. That's good. Okay. Always a bunch of things to make sure they are working. Oh, why can't I see my YouTube chat actually? Okay, so hello, hello, good evening, everyone. So as always, I have a couple of things to say before we begin the presentation. I broke this one. Damn the trend. The Agency of Transport in Brazil. Agency of Transport? Yeah, Agency of Transportation in Brazil. So cars and everything. Cars, bikes, everything like that. Okay, so yeah, first and foremost, a few words before I start this. As always, on those scientific live streams, I always say something before we start. So this is a format that is different from my normal live streams. So in this live stream, we are going to discuss a specific scientific topic. I do this once every week, and this live stream is going to be both in Twitch and also in YouTube, so you can watch in your preferred platform. What else? Yes, these live presentations, they are a bit shorter than normal, because the idea is to pass the knowledge, or pass a bit of knowledge, and then just end it right there, because I don't want to prolong it too long, because it has a specific focus. Okay, what else? And also, I am Brazilian. I normally do content in Brazilian Portuguese. I can speak in English, but I normally do Brazilian Portuguese stuff. Well, apart from the symposiums, but anyway, that's another case. Anyways, what I'm trying to say is, this live presentation is in English, but I will have it a VOD on YouTube, and I will. Well, I have to do this for previous live stream as well, but the idea is I will post the VOD of this live stream together with Brazilian subtitles for my Brazilian community, but the VOD will always be on YouTube. So if you want to rewatch something or try to message me about something that I've said, the VODs are always there, so you can watch it after the live stream. So yeah, that's where today presentation. Closely when I'm in a woman. Well, actually, funny to say that, because okay, not the first, but maybe the second slide is the uterus. So yeah, there were some images of uterus that had the intercourse going on. I didn't like that image very much because it was a bit graphic, but yeah. Okay. Anyways, it's hard to talk about human reproduction without mentioning or showing something graphic. I managed so far, but eventually I will have to do it. Eventually. Oh, that brings me a case. I believe I have never ever made a presentation about male fertility. Maybe that's a topic for the next stream. Talking a bit about male fertility and why male fertility is dropping. That will be a good presentation. Okay, but I digress. Let's get things going. Okay. So okay, yeah, there will be a background music. I hope the volume is quiet enough for me to listen to it as a background music and not too loud to get in the way of the presentation. I always like to have some background noise because whenever I do anything almost in life, I like to have a little bit of noise in the background. I'm not being... It can be, we can talk about that. Surely.
Você não viu nada.
Você não viu nada. Thank you for the alert, player. Okay, let's begin. I'm already prolonging this way too much. Let's go. Okay, let me get the chat. Okay, let's go. So, for anyone who doesn't know me, hey yo, I am Doctor Ekelus, the first Brazilian Scientist VTuber, and today we are talking about conditions for embryo incubation. Let's go. So I'm not gonna talk about the incubation in itself. I'm gonna talk a bit more about what are the conditions for embryo to incubate and to lead to a successful pregnancy. Okay. Just let me get out of the chat over here. Let's go. Okay. So you can ask questions while the presentation is going. I will try to catch those questions and try to answer them as we go. But please, if you have any questions, please do ask. Okay, so let's begin. So, what does an embryo need, right? Well, what is an IVF lab actually trying to recreate? So, in the body, when a fertilized egg, and let me get a little bit closer. I love this image. So this image is from uterus, ovary, fallopian tube, showing exactly where the fecundation happens when the sperm cell meets the egg cell, and everything goes on. You have the formation of a zygote, and the zygote multiplies to cells, 4 cells, 8 cells, etc., etc. And the fertilized egg, it spends like 5 to 6 days on this process, traveling to the fallopian tube, to the internal portion of the uterus, and then to the end of attaching itself in the endometrium. And the thing is, this environment it's dark, it's warm, and it has some specific fluid composition as well. And it's relatively undisturbed because you have systems that hold all of this in place. So, embryologist's job is to kind of mimic all of that in a lab using some specific equipment. And today we are going to talk about the incubation about it. The incubator. So, 4 things we need for a successful embryo. So you need a stable temperature. Human body temperature varies a bit, but normally we keep it at 37 degrees, 37, 36 degrees. You also need a specific gas mixture because in the body, the oxygen is much lower than the oxygen in the air. And I also need the carbon. The carbon is more on the aspect of the pH. I will talk a bit about it. But yeah, that's what you mostly need to mimic the fallopian tube, right? And you also need the humidity and the nutrition from it. The nutrition is made mostly to the culture mediums, and they can change depending on the stage of the embryo as well. Okay, and also there is a stability portion as well, because you can't have any light exposure, you can't have temperature swings, you can really have much vibration as well. All of that disturbs quite a lot actually the embryo, and it makes the embryo doesn't always lead to a viable embryo, but most of the times the embryo doesn't develop as well as if it wouldn't have those issues. Okay. Yeah, also no airborne contamination, no chemical contaminations, and it kind of seems easy on paper, but it's a bit tricky because there are a lot of things that are embryo toxic as well. Video? Yes. Video? Okay. So, even something like paint. If you have a paint that leaves some particles in suspension, some cleaning products, perfumes, nail polish, deodorants, etc., etc., all of that can be embryo toxic. And in the IVF lab, what people normally do, people don't use any deodorants or perfumes that have smells to it, because mostly cosmetic things that have nice smells, have some fragrance, they are mostly embryo toxic. Could high fever or hypothermia inhibit embryo formation? Could high fever, okay, high fever or hypothermia inhibit? No. So your body has your body can regulate the temperature. It wouldn't exactly inhibit the embryo, but it could lead to damages on the embryo. So you could have an embryo that would be would form some abnormalities in the pregnancy. That can happen, yes. I can show an example in my family. In my family, my aunt, while my grandmother was sick, she had a fever, and that fever, because of the disturbance in the body temperature, that led to my aunt being born without a hand, for instance. It's not like in every case it's gonna happen, but it can lead to that. There are many other factors that can influence on that, but yeah, the body temperature is one of the things that can influence on it. Same thing, no problem. Is there a reason why light affected? I get that inside the uterus is dark, but how does it affect an IVF embryo? So the thing about light is because when you have light, you have also heat, because light is a form of heat. So when you have an IVF lab, it has some protections on the... how can I say this? Do you know the yellow lights we have on many houses? We can't have that in an embryo lab. Yeah. So in the embryo lab, we don't have direct sources of light, but we have protection on the light for it not to generate enough heat to get to the embryos. An embryo lab is it's quite expensive actually, because you have to keep many things in consideration. Apart from one of the example is the cleaning products. Cleaning products, they need to be like the cleaning products you use in hospitals, because they can't really have any smell. They can have a lot of chemicals that would be embryo toxic. So yeah, it's quite a difficult place to make it as clean as it needs to be. Oh yeah, there is also mechanical vibration is also something that can influence it. So many, I believe most incubators for embryos, they have stabilizers, so it can be really stable. But when you have some older models that don't have those stabilizers, if you leave like a centrifuge running next to it, it can be a plausible stressor for the early stage embryo, for it not to form as well as it should be, or it should be forming. Wait. Okay. Why does it matter? Okay. So, as I was saying, the variables behind IVF are plenty and they are pretty wild. So, two clinics can use the exact same stimulation protocol, the exact same transfer technique, and have and still have meaningful different pregnancy rates. There's a huge amount of gap that traces to lab culture, conditions, equipment quality, the staff technique, the patient situation, etc., etc., etc. And also, the patient's situation is one of the things that affect a bit as well, because age is also a factor on embryo quality. So, this is a graphic on the live births per intended egg retrieval. It's quite funny actually, because those informations are always public. Whenever you have a fertility clinic, you need to submit all your data of your clinic to a database, and that database always has the summary of the year. So this, I believe, was from last year, so 2025. So yeah, so a bit of temperature swing, culturing at the wrong oxygen level, shifts the blastocyst formation and pregnancy rate outcomes as well. And this is a field where really close enough doesn't really catch it, because, I mean, it's a possible life that you're dealing with, so it's quite tricky, as you can imagine. Normally, patients Normally, patients do try to research a bit on getting more knowledge, but sometimes it's quite easy to get lost on all the information there is on IVF, because there are a lot of information, but not as much quality information, you know. Okay, one thing an embryo needs is a nutritious environment, yes, but this environment doesn't have to be inside the uterus. Ectopic pregnancy, what are the tissues that are nutritious enough for the embryo to develop in? Oh, okay, that's a good question. Let me see if I can look for it. Give me 1 second. Let me see if I can look this real quick. Okay, there we go. Wait, no, I need the image actually. Okay, this should be good. Open image. There you go. So, whenever you have an implantation of an embryo, like this, and I'll also get the YouTube chat as well. Okay. Whenever you have an embryo implantation successfully, so there are some hormones and some reactions that happen in the tissue that can lead to blood vessels forming up, and those blood vessels forming up, they kind of make a primitive kind of placenta. It's not really a placenta, but it's something like it, but primitive, where the embryo can take the substrate and the material it needs. Is that intuition of sincerely, almost every tissue that has blood vessels is nutritious enough for the embryo, because it develops in a way that it can bring those blood vessels to it. So that's the issue with ectopic pregnancies, because you don't know where the embryo is going to accommodate itself, and whatever it can accommodate itself, it will grow and it will try to develop into a fetus. And you don't want a fetus developing in your in some places. You absolutely don't want an embryo to be developing. That can be for sure. Crazy, I love it. Yeah, it's interesting. It's interesting because it is so good that it can be a detriment. It can live to death. Yes, it can live to death. If the sorry, if the embryo attaches itself in some tissues, it can be really dangerous and it can lead to death because it will disrupt a lot of things while it's growing as well. Okay, come back. Start time. Let's go. So this right here is a timeline of the things that happen in the embryology field, and there are still many things to come. But as I've showed in previous live stream, where we can see the map with science and how science evolves, we have gone quite far in the fertilization aspect of it as well. But I want to point out some interesting things. So one of them is in 1944, where the first claim of human in vitro fertilization comes from. This was the first try of fertilizing a human egg outside the body. Was nothing really sophisticated, but and it didn't really reliably work. So those two authors, it's Rock and Mencken, they managed to get 3 embryos out of 138 attempts. And even then, it was quite unclear if that was really fertilization. One of the biggest problems with ectopic pregnancy in the past was, where is this thing going to come out? Long live medicine, yes. Well, we now have, I don't know the name in English for this. Cesarean part? Cesarean birth? Where they can cut the mother's belly and to get the baby out of it. I think they can still do that in some cases. In ectopic pregnancies. Mucho taste. Indeed. Cesarean, I don't know. Is it cesarean in English as well? C-section? Ah, it can be. It can be. Let me see if the translation is that. The pioneer. Let me see the translation for this. I've never asked for it. Translation. Yes. Oh, it is cesarean. Oh, okay. Yeah. Okay. Cesarean. Cesarean. Okay. Misspelled. Hey, good to know. And come back. Okay. Okay, come back. Yeah, so 1994, no, 1944. We also had 1978. We all know it. Well, as is, I've said it quite a few times. 1978 is the first human IVF baby, the Louise Brown. And then 1985. Where is 1985? Yeah, 1985 should be somewhere right here. Okay, so 1985, there was apparently comes from the myth that Caesar was born via C-section. Okay, I didn't know exactly that. Man, I want. Oh, there is a VTuber that is also a medic, right? Maybe I should try to ask him. That would be an interesting idea. Collab with the doctor and another doctor when. Okay, so 1985, 2 doctors had published a formula that they call human tubal fluid medium, and that's the medium design. Let's go. I have to try and see if the doctor would speak to me, but I think it could happen. Absolutely. So, yes, in 1985, they designed a chemical to mimic the the composition of the fluid inside the fallopian tubes. That has advanced on the medium we use for the embryos as well. So, in the 1990s, there was the first PGT. I don't know if you guys know what PGT means. So PGT is pre-implantation genetic testing. So what it does, it consists on screening the embryos for genetic and chromosomal abnormalities before we can make the transference and before the implantation of that embryo. So what we do is we take one cell from the embryo when it is on when it has a lot of cells. We take one cell and we analyze it for seeing chromosome numbers, genetic diseases, and something like that. It is a bit invasive, but nowadays it's a bit more common. Well, there are also different types of PGT, but we can explore a bit more on it on previous live streams. Okay, and 2010 and forwards, we have the new techniques. One of them is the time-lapse incubators, the cryopreservation by vitrification, and some others. And we are not done yet. There are 4 more things yet to come in the fertilization and reproduction research. Okay. I will show some things that happen are happening in this year. Because my brain is frying just by looking at it. This is only the timeline, but yeah, it's quite a long timeline. I don't know if I can get it. Let me see if I can get it. I don't know if you guys remember the map. It's a bunch of things. Let me see. I believe it was on the bioethics, right? Yes, it was on the bioethics presentation. Remember this? Yeah, this is the timeline of science history. I love this. I absolutely love this. Look at how much stuff have we done. Oh my god. I love this. Yeah. Okay, I'm considering making it my wallpaper actually. Quite a lot of things. Oh, please don't. Please don't. Okay. Let's go. So, let's talk a bit about the temperature. What we need. So, cellular machinery that is responsible to pull chromosomes apart in the cell division. They are remarkably temperature sensitive. Is there a place where we can download it? Oh, I don't. I can provide a link in the Discord for that. I think I will do that. After the live stream, I will do that. Thanks for letting me know that you want it. Okay. But yeah, so the cellular machinery is quite temperature sensitive. So there's that. And the embryos have been shown to start depolymerizing or becoming unstable at temperatures lower than 36 degrees Celsius. So it can affect the spindle apparatus that is inside the cell, which can lead to potential chromosomal misgregation. So then you have a lesser number of chromosomes, and it can lead to a number of chromosomal disorders. And also, the thing is with older incubators, the culture dishes, they needed to be pulled out of the incubator for you to do a routine. For you to handle it and see in what stage the embryo was. And this is why the time-lapse incubators have become a huge technology for us, because we can see in real time what's going on with the embryo without taking the petri dish out of the incubator. And also, the motor systems are specifically designed to let us watch it in a continuous development. And also, there are some moments where handling can't really be avoided. We have to manipulate the petri dish, but some new engineering has been emerging. So we have heated bases, heated microscope, and heating handling surfaces as well, to keep always the temperature stable inside the petri dish. Oh yeah, oxygen. Let's talk about oxygen a bit. Let me get this a bit over here. Okay. So another thing in embryo culture for incubators is to have quite a bit less oxygen, because regular room air is about 21% oxygen in the air. And inside the fallopian tubes in the uterus, the oxygen levels are much lower. They are somewhere about 2 to 8%. And in the most cases, the standard practice in IVF labs has borrowed from the older techniques for culturing other kind of cells. So we are using mostly around 5%. Oops. Wait a second. Okay. Just a second. I accidentally hit a button that I wasn't supposed to press. It was worry on the oxygen. Okay, there we go. Let's check as well. Okay. So previously, in the IVF labs, it was used the 21% on oxygen, but we've seen that it wasn't really that good. And when we tried with a lower oxygen concentration, we have seen the values of the clinical pregnancy rate go up. So yeah, if we lower the oxygen, we have a higher pregnancy rate. Let me drink a bit of water. So the reason of why a lower oxygen concentration can lead to a higher clinical pregnancy rate is because of reactive oxygen species, the ROS. They are particles that are free in the oxygen. Ectogenesis. Not really ectogenesis. But hi, Merlin. How are you doing? So the reactive oxygen species are unstable molecules that can damage cellular structures, and they can subject the embryo to a chemical stress. So we do anything to not stress the embryos. Anything. I guess this is the standard approach. It is. So also the ASHR. So it is the European Society for Human Reproduction and Embryology, has also updated the official good practices and guidelines to recommend the culturing of embryos at a lower concentration of oxygen as well. Okay? No more than 8%, no less than 2% of oxygen. Okay? Didn't they try testing with other oxygen concentrations? They did. They did try lowering this until they got to the 5%. 5% is the most used, but it can differentiate a bit because not all IVF labs are the same. Because not all IVF labs are in the same elevation. All IVF labs are in the same air quality as well. So all of that can lead to a bit of difference. And it comes also apart when you look at the CO2 and the pH. And also this is like a panel from the incubator where you can set the temperature, the percent of CO2. You can manage those things. You can also manage the O2 levels, but it doesn't show in this screen. So yeah, so on the pH and carbon dioxide, standard embryo culture is bicarbonated buffet, meaning its acidity is chemically controlled though through a reaction involving dissolved carbon dioxide, which means the pH median depends on how much CO2 is in the air of the incubator. Typically, it is maintained about 5 to 6%. So I don't know if you guys ever saw the correlation, but there is a correlation between the level of CO2 and the pH levels. So the higher the carbon dioxide, the more acidic, the lesser is the pH. Okay, that's what I'm trying to say. So the higher, yes, the lower the carbon dioxide, the higher is going to be the pH. So this is why we altered the CO2 in the incubators as well, to keep the pH stable. Oh yeah, and there's an important detail, the medium that we use. The culture medium, it has to be allowed to calibrate inside the incubators before we can transfer the embryo to it, to the medium culture. Keeping all of this, keeping all of this is a well-documented, avoidable source of embryo stress and damage. And the peroxide button seemingly. Yes. Oh yes, that's I mean, there are some incubators that are more general use, so you can have other types of culture on it. I assume it would be maybe for cleaning as well. Maybe. Expected. CO2 does indeed acidify the environment in which it is released. Yep, it does. So that's a correlation and why we control CO2 in the incubator. Okay, I'm gonna switch this song. I don't like this song that much. There you go, that sounds bad. Yeah. Alright. Okay, now let's go see the time-lapse incubators. This is really fun. So, the innovation with the time-lapse. Let's see if I can play it. That's gonna play. So, this right here is an embryo. Oh, you can see that. So the innovation with this system is we have a camera inside the incubator. So capturing the image every 5 to 20 minutes, and we don't need to remove the petri dish to look at it. It's so good to see. Human fertility, that's so inappropriate. That's so inappropriate. Look guys, a sperm cell had to enter an egg cell for this. I assume they don't use media such as FBS for this, do they? No, it's not FBS. I've used FBS before actually, but no, we don't use FBS for that. It is another medium, and actually there are two types of medium you can use on an IVF laboratory. You can use a general medium, where you can just leave the embryo there and it goes from like the early stages to like the multicellular stages to a morula and a blastocyst and everything. So and you also have another idea, another method that is switching mediums for each stages of the embryo development. So which is better? It depends a lot. Every lab kind of does what it works for them. But yeah, there are two viable ways for using medium. I won't really remember the name of the medium right now. But yeah, I know there are those two ways of doing it. Should I let Neps Discord? No, we are learning how babies are made. Well, I can... Okay, I have already promised to make a live stream on male fertility. Maybe I will advertise more about that. Sounds good? I just love to see how magical this is. Like you have one cell, and then you have two, and then you have four, and then you go and you go and you go. That's so good. I love seeing it. Also, Sama, hello! Heyo, heyo! Nice to meet you. Thanks for the follow. I'm afraid of those illustrated images of male fertility. Well, probably there will have to be a penis somewhere, probably, because, well, I need to show it, right? Because of infertility aspect of it. I will have to show it eventually. It all starts right there. The instructions become someone's entire body exactly. It's so magical. I love seeing it. Oh yeah, there's also another thing that is good with the time-lapse incubators is because it makes this video so a lot of embryologists can look at the same case and have different interpretations. So it is very good for training, it's very good for quality assurance, second opinions on difficult cases, because obviously this is a good case where you have all the divisions accordingly. But whenever you have a case where the divisions aren't that good or something's going wrong, some embryos develop way too fast, some embryos develop way too slow, you can all see that. You can see all that in the time-lapse incubator without needing to like take the embryo out of the incubator and seeing it on a microscope. Yeah, it's very, very good. How much of a risk is DNA damage during the process of incubation? How much of a risk DNA damage? I don't quite understand the question. Are you asking if how much damage there is of DNA damage, or how much of a risk is DNA damage during the process of incubation? Or are you questioning what happens if there is DNA damage and we let the process continue? I don't quite understood the question. Didn't quite get it. Okay. So, yes, I want to talk a bit about vitrification as well. The live stream. Vitrification is one of those things that is really interesting to how we managed to do it, because it's quite... I don't know who came up with this idea. What amount is tolerated during the process? Do certain factors risk appreciably increasing DNA damage? Certain factors risk factors? Generally not a concern. No, it is a concern. It is a concern. So, what amount is tolerated? There is an amount tolerated for damages. We can see that with the PGT, which is the pre-implantation genetic testing. Grab your pots and pans. I will have to The recipe for embryos. Oh my god. However, normally if we see there is some damage, some DNA damage previously. So if the embryo is taking too long, if the embryo is going too fast, that are all signs that something could be wrong with the DNA. Because of the many reasons, like embryo toxic components in the air, the filters of the air filters of the IVF lab are not working correctly. There was the cleaning staff used different kind of chemicals, and it had embryo toxic components on it. Everything like that, it can affect, and it will eventually show up in the process. If it doesn't show in the process, if it isn't enough DNA damage to show, then we can see in the PGT test, where we take like one cell from the embryo. Doctor Ekelus. So like maybe around this stage, like this. Around this stage, we take one cell from here, and we can see the number of chromosomes, the amount of DNA damage, or if the DNA is okay of this embryo specifically, and we can try and see if the embryo is good for transfer. There is also a situation where we take, well, we don't actually just take one cell from here. We normally take a few more cells, because there is also always the risk of mosaicism as well. So we always do that. No, not always do that, but every time we do a PGT, we do that. Not a robot, and try. Hopefully that answered. Okay, yeah, so the factors that influencing DNA damage is all of that thing. All that is embryo toxic can have some effect on the DNA, and that's why they are considered embryo toxic. Okay, switching up to vitrification, which I also find is quite dope. So, okay, this technique, the vitrification, previously, when we wanted to, yeah, thank you. Oh, you're welcome. They are trying to invent names for me. Okay, previously it was okay. It was what? Ekelus. So, okay. Previously we did the slow freezing process, but the slow freezing process has one issue. I don't know if you ever saw a cell being frozen, but whenever you try to freeze a cell, what happens is there are formation of crystals, water crystals, and they can disrupt the cell functioning when you defrost it. So what we have come up with is vitrification. And vitrification is a process that freezes the embryo in a manner so fast that the water inside solidifies directly into a kind of glass-like state. So it skips the crystal formation step. It's easy to freeze small cells and tissues, but more difficult for larger ones. Yes. But making sure the ice crystals don't kill the cell is tricky. Yes, it really is. Glass-based water. Yep. So, let me see. It shows like how we do this. So here you have the gamete medium. This is for freezing egg cells. So you have the gamete medium, and you have an ES step where you have a medium for that. Also a VKS step, so another medium. So you use two different mediums with cryopreservants, and then you we use liquid nitrogen to freeze. So you insert that on a no compartment that has liquid nitrogen, and then you have successfully crystallized, vitrificated the cell of your interest. Did you? And then you have the warming. So for the warming, you have also some other mediums that you place the egg, the cell of your interest, for it to defreeze. So you have another medium, and then you have another medium, another 2 mediums to do the after vitrification process and to utilize the cell again. Yeah, done correctly, vitrified embryos, they can show survival and pregnancy rates relatively comparable to the fresh, never frozen embryos as well. And that's why frozen embryo transfers have shifted within a couple of decades from being treated as a fallback option to being more of a routine. People want to vitrify more stuff because they want to preserve more stuff as well. I don't know how many people you know. I know quite a lot of women that are freezing their egg cells as well. Fresh never frozen. Fresh never frozen. Great advertising slogan. Indeed. How long can a vitrified embryo survive? How long do you want? how much nitrogen? How much nitrogen do you have? How many nitrogen tanks do you have? That's the question. But yeah, well, there was a case from last year. Yeah, there we go. This case. So a baby boy named Thaddeus Daniel Pierce was born in Ohio from an embryo frozen in 1994, making him the world's oldest baby. So this was in 2025, if I'm not mistaken. Yes, as long as the infrastructure holds it. So there isn't really an end date of how much can you keep an embryo frozen. Okay. Maybe radioactive potassium isotopes could be an issue. I don't know. Radioactive potassium isotopes. What you mean by that? Yeah, say that. Yeah. Yeah, and this is what I was talking about. The trend of plant oocyte cryopreservation over time. So, women are generally trying to cryopreserve more of their egg cells. The poor fellow was born old. Yeah, well, I mean, it is that kind of situation. Is him like 30 plus years old, or is he just 1 year old? How do we count it? I remember that being an issue in discussion of long-term human stasis for futurism theory crafting. Okay, I can see that. Why can't we just make I mean, it is a dumb idea, but if we could separate every cell in your body and freeze every cell and then try and mix it up again? Maybe. But yeah, I don't think cryopreservating an entire human would be possible. Well, at least not with our technology. I cannot sure. Okay, but yeah, I know a few women that are beginning to freeze their embryos, their egg cells as well. I don't know if you guys know many women that are doing that. Teleporter problem, indeed. And I also know this technique, at least Yeah, not with this technique. So, what is next? What are we looking up for? So there are a few active frontiers, starting from gene editing. So yeah, so this right here is a preprint. So it is not really a finished article, and it is not. It has not been peer reviewed as well, but it is either way a study. Oh, okay. The video is on top of it. So I just have to zoom it out. Don't shake the embryo. Don't shake the embryo, please. So efficient base editing and development in human embryos without chromosomal alterations. So what are they trying to do? They are trying to edit some genes without mixing too much the chromosome. So it is the thing they are trying to do. This is relatively new, actually. I believe it is from this year, I think. Yeah, it is from this year, 2026. But it's still a preprint, so there are a lot of things that can be improved with that. There is also this is really cool. Is this space related to CRISPR? Yes, it is. It is. They are trying to use CRISPR to edit some genes without mixing too much with the chromosome. And I mean, CRISPR is a bit... Well, I love CRISPR because one of my first ever interactions with science was with CRISPR. CRISPR and salamanders. I love it. Okay. Over a very long span of time, even if the material is otherwise chemically static, unstable potassium 40 isotopes will decay and cause radiation, those over long periods of time. Okay, that makes sense. That's the case for freezing humans, right? How do you edit the genes without altering the chromosomes? I don't know, but they crispy. They are trying to do it. I don't know how exactly. I haven't read the entire preprint, but I have to read it sometime. Maybe. How it is a preprint? Maybe we can read it in a live stream. I don't know. I would have to check that. Fred, no, don't breathe the bells, please. Okay, this is another interesting thing. Let's see if we can. Oh, okay. That sounds like writing the document without touching the sheet of paper. It sounds like writing the document without touching the sheet of paper. Not well. Yeah. Well, again, it is a preprint, so I don't really know how much of it is actually possible of what they are doing. And it is a preprint, so no one has reviewed it so far. Or at least none that I have seen of. So, okay, come back to this. This is an incubator, and this was on Azure this year, Azure 2026. These here are incubators, and what this guy is doing, he's going to take like a bay out of this incubator, and it is heated, so he can take the incubator and take it to everywhere else in the lab.
Let's go and make an Embryo transfer.
There you go. Look at that.
It's wonderful. It's keep temperature and CO2 for 30 minutes?
30 minutes, yes.
Wow.
Yes.
Thank you.
Continue. Fair. Maybe they just jam plasmid in there, but would they need CRISPR for that? Maybe this is. I mean, gene editing nowadays always use CRISPR, right? I don't think you can. I don't think you can do gene editing without CRISPR nowadays, can you? Oh, a portable incubator. Yeah, the portable incubator. It's really needy. Because if you haven't said that it was an incubator. Who would have thought it was an iPhone? It looks like an iPhone case, doesn't it? And the way he is handling it as well.
Embryo transfer.
Yes.
Also, by the way, this is the way we use to transfer. This is the way we use to manage. Oh, you guys aren't seeing. Okay, let me see if I can make the video bigger. Get this over there. So the way he is holding the thing is also one of the ways we use to handle the petri dish. So the petri dish comes in contact with your hand because your hand is on a higher temperature, so your body temperature, so it doesn't disrupt as much the embryo inside the petri dish. That's a neaty detail. And also this one is also from Asher. This is a robot that does pipetting, so micro pipetting. We don't need we don't need people to get medium and dispense it in petri dishes anymore. There is a robot that does that. So as you can see, it has like many pipettes right here, and it can take the medium, and it also can take the petri dish. It loads the petri dish in this platform right here, and it does the pipetting for you. So yeah, we don't need people to pipette anymore. The AI is going to do it for us. They taking my job? Oh no. Yeah. Okay. And also, none of those are standard practice because they are very, very recent. But, well, with how much the field has advanced, right? With how much the field has advanced, I wouldn't be too sure on this not becoming mainstream within the next decade or so. Yeah. Yep, but that was it. That was it for this livestream. This is the frontier science, the final frontier. Yeah, yeah, but that was it. Thanks very much for watching, guys. Thanks very much. Thank you very much. Thank you very much. And also, I can't end without saying, don't forget, please, to leave a like, subscribe. It really helps the channel keep making science content like this. It was a pleasure sharing this knowledge with you. Scientific hugs from the doctor, and I'll see you in the next video. Yeah, that's it. Okay, guys. Oh my god, okay. Okay, just let me check if there is someone. Thank you for the presentations. Oh, thank you for being here. Please, if you have any more questions, I'm free and you can ask away. Thank you very much. Thank you very much. Let me. What is the best image of the presentation? Oh, let me keep this rolling. Can I make this a loop? No, I didn't think I can. I can't make it a loop. Okay, that's too bad. Yeah, but that was it. Thank you guys very much. Let me get ahead and close this. Come back to here. Oh. Okay, so as of how this works on YouTube and Twitch, I am now going to end the transmission in YouTube, and shortly I will end the stream also on Twitch. But yeah, thank you very much. Thank you guys very much. Maybe next time we will indeed do the presentation on the male fertility. I think that's a good topic. Okay. Oh, the assistant. Is the assistant online?
__ guia.
Oh, she's online.
Before saying goodbye, you wanted to ask, how are you, Miss Assistant? Oi, tudo bem por aqui?
She's responding in
Ando a
Portuguese.
mil no laboratório secreto com o Dr. Ekelus clone, ajustando a matriz de energia demoníaca para o próximo experimento do Mr. Y. Mas sempre arrumo um tempinho para nossas lives na Twitch, é ali que eu recarrego minhas baterias com vocês.
Thank you for perfect.
Mesmo sendo meio demoníaca, estou me sentindo mais humana do que nunca,
No questions.
animada,
It's okay,
curiosa e
Thank you very much.
preparada para encarar qualquer desafio científico ou infernal que aparecer no caminho. Obrigada por perguntar e por fazer parte dessa loucura maravilhosa.
Oh, she was it. Okay, yeah, she was responding in Portuguese. Basically, she's okay and she thanks you all for being here as well. Yeah, that's it. Okay, ending it now. Is this Brazilian AI assistant? Yes, AI assistant. She's not a real person, unfortunately. Okay, ending on YouTube. Say bye to YouTube. Bye 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 YouTube. See you in the next one. Bye bye bye.